Okay my dear, so this is Ujjwal Kumar saying, and in this video tutorial I'm going to share with you about NTU. Well, I hope you know about NTU. Well, the full form of NTU is number of transfer units. So as you know, NTU is one of the most important topic if you are preparing for GATE examination, because they have already asked question in GATE 2009 for 2 marks. Directly they have asked question, well little bit related to heat exchanger, because this is a topic inside the heat exchanger. So what we are exactly going to do in this video tutorial, I'm going to share with you what is exactly NTU first, and second an example with you. I'm going to share with you example. That's why you can do much better, you can understand it, how to solve numerical problem if in any examination, maybe competitive examination, maybe university examination, you will get such question. You can quite easily solve the problem. Okay, I hope you are getting me right. So you are getting me, I know that, because it's been long time I have been making videos and there are thousands of students and we have been overwhelmed from your response. Thank you very much for watching our videos, well my videos of course. Okay, so let's go for it. So basically what is NTU? NTU is number of transfer unit. NTU is equal to UA by MCP, and here one thing I am just notifying, that is minimum. U is overall heat transfer coefficient, A is area, M dash mass flow rate kg per second, and Cp is specific heat. But here what is the meaning of minimum? That is important, because without knowing this concept we cannot solve problem quite easily and accurately, because we'll be in confusion while solving problem if any question asked related to NTU. So first of all we need to understand its basic concept, what is MCP. So MCP is also known as heat capacity. Okay, so let's go for it. Suppose that we are having a heat exchanger, okay, that is a parallel flow heat exchanger. Suppose that we are having a heat exchanger, parallel flow heat exchanger. So in case of parallel flow heat exchanger, our heat exchange like this. Suppose that this is TH1, this is TH2, this is TC1, and this is TC2. Okay, so as you know, this is there definitely mass flow rate something, there definitely Cp, there definitely some values will have for this hot fluid, and for this cold fluid the same, there should be some values of, there should be some mass flow rate, and that fluid must have some specific heat at constant pressure. Okay, so this is about it. Here what we have to do, we have to find out total value of MCP for cold fluid and total value of MCP for hot fluid. Then we have to compare which one is minimum, and that one we have to use here for finding out U, that is heat transfer, overall heat transfer coefficient, I must say that. Okay, so this is about it. Now if we don't have given the value of U, then how we can find out that? So we know that formula, there is a formula, Q is equal to UA theta M. This theta M is known as LMTD, logarithmic mean temperature difference. Okay, now we can find out this U from here. We can find out this U from here. So we don't need to have panic for that, we can easily find out, okay, that thing. So okay, so I hope you understand about it. Alright, so let's go for it. Now most important, what is the unit of Q? That is joule per second or watt. First. Second, what is the unit of LMTD? Maybe in centigrade or Kelvin. Okay, now what is the unit of area? Meter square. And U, watt per meter square, Kelvin or centigrade. Okay, so this is about it. This is about the all data, all things we can use here to find out NTU. Now if you will say what is LMTD, well I have already shared with you what is LMTD and how we can find out. Logarithmic mean temperature difference, we can easily solve problem related to it for parallel flow as well as counter flow heat exchanger. Well, in this part of video I have shared with you what is NTU and how we can relate these things with this one and this one. So only knowing the formula of NTU cannot help you in good competitive examination. You have to know its root basic concept. Okay, so this is about all this is about this is about NTU and other things I have shared with you. Now suppose that we are having a we have given a numerical problem. Okay, suppose that we have given a numerical problem, because I know there are many around 70% of my students are preparing for GATE. So they're watching these videos only because of GATE. So I'm focusing to help them to get basic concept as well as some important tricks to solve problems with accuracy, with maintaining accuracy, because without accuracy, what's the use of solving problem? So suppose that we have given a numerical problem. Okay, so in this problem we just need to consider, I'm just going to consider this. They have said that there is a parallel flow heat exchanger, and hot fluid mass flow is 2 kg per second, and CP is suppose that 4 kilojoule per kg Kelvin, and here mass flow rate is suppose that 4 kg per second, and CP is suppose that 3 kilojoule per kg Kelvin. I hope this is visible. That's why I am using different color marker. So that's about it. So suppose that we have given these two values, okay, for any parallel flow heat exchanger. They said hot fluid is flowing like this and cold fluid is flowing like this. Their value is this and their value is this. Okay, so this is CP, this is CP, this is mass flow rate, then this is mass flow rate. That's why I have denoted here M dash. M dash means mass flow rate, means kg per second. Okay, if we are considering kg, or gram per second can also happen. Okay, so this is about it. Now suppose that they said find out NTU for this parallel flow heat exchanger if they have given these values. Now they said area of the heat exchanger, suppose that 5 meter square, and overall heat transfer coefficient they said around 2 kilowatt per meter square Kelvin, right? So here we can easily write that N2 is equal to UAMCP, and CP is required minimum value. So we need to consider also that thing. Now we are having, where we are going to make mistake, you will just write 2 here. Don't write only 2, just write 2 into 10 to the power 3 because kilo is there first. Second, we have to write area is 5. Now third, we can easily understand which one is minimum, that is 4 multiple 3 12, 2 multiple 4 8. So yeah, 8 is minimum. Okay, so that's it, that's about it. Now we can easily use calci. Well, by the way, you cannot use this calci in GATE examination. So 10 to the power 3 into 5, 2 multiple 10 to the power 3 into 5 divided by 8. Okay, so this is 1250. Now do you have any idea what is the unit of this? Can you guess what is the unit of NTU? If you don't know, or maybe you know, I don't know about you. Okay, so can you guess what is the unit of NTU? No? Okay, let me share with you how you can find out unit of NTU. Well, it is actually dimensionless, but how can we so sure that unit of NTU is dimensionless? So you know that the unit of U is what I have already shared with you, what per meter square Kelvin, area meter square, mass kg into second. Okay, now CP in kilojoule per kg into Kelvin. Okay, now what is meter square cancel, Kelvin cancel, and kg, okay, there is something missing here, kg is there, kilojoule also there. So what we got here, second Kelvin and this is what means joule per second. So second cancel, what remaining, joule and Kelvin cancel, so what we got, joule only. So joule means Newton meter, Newton means mass into acceleration, kg meter square per second, second will be cancelled there, right? And meter is also there. So after calculation we got here dimensionless, we will not get any dimension of this. That's why this NTU is dimensionless. I hope you are getting my point, right? So this is all about NTU, and it's all important things about it. Okay, so I hope you understand what I mean. I wanted to share with you, and thanks for watching. See you soon in my next video. Bye bye.